There are many advantages of using nanotechnology in textiles because we can impart functionalities to textiles in a more controlled manner and with less raw materials. We can also create new functionalities. In our lab, we like to manipulate fibers into doing things they don't like to do. For example, we can make cotton to kill bacteria. We can make cotton to conduct electricity. We can make cotton to serve as an electrochemical transistor, or cotton to capture toxic gases or active compounds such as vitamins or cosmetics. So many advantages to use this knowledge at the nanoscale and apply it into larger surfaces like textiles. I believe that the interactions between scientists and designers are extremely important because these interactions can create spaces of incredible intellectual and creative wealth. Scientists and designers follow two different ways of thinking, two philosophies. And if we combine those two philosophies, we can make our science more relevant and appealing to the community. Scientists used to tackle a big problem, by dividing the big problem into smaller problems. We find local solutions, and then we compile these local solutions into a bigger solution. But designers have a more holistic approach. They see the final concept from a larger perspective, and they can actually come back down to the details. By taking advantage of these two approaches, and interacting together, we can provide solutions to problems that are not possible by either a scientist or a designer working by themselves. And I can say that I'm a better scientist, and my science is better because I've worked and interacted with designers. Well, that's a difficult question because I want to think that most of my projects are very exciting. But my favorite molecule is cellulose, and specifically cotton. And we have worked on making cotton antibacterial against E. coli and Staphylococcus bacteria. We have also created color without using dyes or pigments, just using nanoparticles. We had made cotton electrically conductive, and also use cotton as a substrate to create electrochemical transistors. And we created cotton into a structure capable of capturing gases in a very selective manner and encapsulated compounds like medicines or vitamins or cosmetics. On the basic level, we also have discovered very unique phenomena and developed new techniques to measure existing phenomena that can produce better lubricants, better anti-static treatments, and better coatings for textiles. All these projects involve a large number of students over many years, students with different backgrounds, international collaborators, and funding agencies that have made all of them possible. So I think these creations can see the high street. We produce mostly chemistry that is water-based and that can be replicated using existing textile manufacturing facilities. We are a university, and our main goal is to produce science and train the next generation of scientists. But by working with companies and industries that have licensed these technologies or hired our students, they have been able to incorporate these new developments into their production lines. There are many challenges for the interaction between scientists and designers because we are training totally different approaches and philosophies, so we have developed different sets of values or what is important to each one. For example, for a scientist, getting a publication in a high-impact journal and getting a lot of citations from your colleagues can be a very worthy goal. But for a designer, having a very well-critiqued and publicized collection or exhibit can be equally important. The trick is to respect each other's disciplines, and I believe that we can achieve better outcomes by interacting together. And take a look that I don't say working, I say interacting, because that's the key. It's these two disciplines interact at each step. Instead of simply dividing the task, we can achieve a better outcome. If you use the approach, I do this and you do this approach is only additive. You are adding expertise and skills. But by interacting with each other, we can create a multiplier effect, a much more powerful outcome. Perhaps the issues of scales and dimensions is a difficult challenge because we see small things and they see bigger things. We see the world with different magnifying lenses. So, but it's a great and fun experience, sometimes frustrating, sometimes challenging. I will say that other challenges can be people in your own discipline or in your own community that have a very traditionalist or Puritan view of your field. So I will tell you, when I started working in these endeavors of collaboration, I was given a warning by people in the science side that I was wasting my time working with designers. And I was reminded by the designers that I was not one of them. But the key is to smile and to move on and use that, believe that these multiplying talents can be a worthy goal. As I mentioned before, I'm a better scientist because of these experiences with designers. I still produce my scientific papers, my patents, my developments coming from a lab in a scientific traditional environment, but now I can make science more relevant to the community. And I can argue that it's equally complex to design a molecule than to design a dress. We just need different type of skills and interests, and we can work together. This can make happen and can produce an outcome that is not possible but each one working by themselves. So the future is exciting and unpredictable because now, because of nanotechnology, now we have unique control of matter at the nanoscale. So we can create unique functionalities in clothing that were not possible before. We can make clothing to be an interactive surface that can serve, for example, as an electronic sensor without using wires. We can create textiles that can give you medicine.